Yes, sir, we can continue.
Yep. So today's agenda is to cover the fundamental of MPLS, how exactly MPLS works, what is the MPLS versus the traditional IP routing, then traffic engineering and the QoS part, brief about the use cases, and then last it will be Q&A session.
Yes.
So we frequently hear about the MPLS, but what exactly it stands for? So first EM is come for the multi-protocol. So it supports all of the protocol which are available in the networking domain. It could be IPv4, V6, IPX, then old protocols like token ring, ATM, all these protocol it supports. That's what it called as a multi-protocol, and it works in the OSI 2.5 layer between the layer 3 and layer 2. That is layer 3 is network layer and layer 2 is the data link layer. So it works in between that one. The next one, L stand for the label. So if we talk about the IP, that is 32-bit, and when packet hits to the routers, router needs to do the routing based on that IP address. But label is very short form of that. So routers created the short labels for that one, and then they switch based on that incoming label, and they push the outgoing label on top of that one, and they will push that one. So this is the label header for that one. So this is the layer 2 header. This is the MPLS header situated between that, and this is the IP packet which we got from the customer. So it is 32-bit and it contains the label, then EXP value which we are going to talk in the QoS section, and this is the bottom of stock, so that router should know that this is the end label, because if we talk about the VPN, we will have multiple labels there. So router should know that what is the last label, and this is the time to leave value, so that in case if there is loop in the network, then packet should not move around the network continuously. If TTLs become 0, then packet will be drop in the network. So this is about the label. So if we capture those packet in the Wireshark, it looks like this one. So first one is the layer 2 header, that is Ethernet header, and then it will have the type value to identify what is the my next packet. And we can see here it push the label value here, then all this information related to that label. Then third comes as a switching. So switching works on the layer 2 side, and then routing works on the layer 3 of the OSI layer. But this MPLS works between data link and network layer, that is 2.5. And what does switching means? Means let's say that if I'm getting any particular packet with the MPLS header on it or MPLS label on it, I'll just take it and then I'll see where I need to send it, and then just push it on that next hop. So I'm just switching that packet. I'm not doing routing. So we will see in the subsequent slides what is the exact difference between switching and routing. I think here we will see that what is the exactly difference. So let's say in this first scenario, this is the network situated at a other end of the router, and this is the another network. So both having different IPv4 address, and then router can switch the packet between both of these networks. What exactly routers can do? Once packet hits, it needs to process that packet first, and it needs to figure out, okay, I need to send this packet towards that one. So what is the best possible path to send that one? Because let's say if we are walking on particular road, so we say that route. So if we land on any junction, so we see that which is the base direction, based on that one we proceed there. So same principle works here, that once the packet hit to the router, it needs to process that one, and then it will forward it to the whatever destination is there. But that is not the case with the switching, because the label value comes with the particular X value, and already the forwarding table is already populated with those value, and just I need to take that label value, push it the another, and switch it to the next of whatever it is there. So it's not processing that packet, it is just simply taking from here, adding that adding or moving those labels based on this action, and then immediately push that label to the interface which is connected to the other domain.
Right.
So is it clear about the switching and routing?
Yeah. Yes.
Okay. So how exactly MPLS works? So there are two scenarios in the MPLS. First is the control plane, means first we need to advertise those labels, MPLS labels, and then second is that it should be pushed in the data plane, and it can be used in the data plane. So to advertise those in the control plane, we have the protocol like label distribution protocol, then reservation protocols, then advanced protocols like segment routing, and then BGP. So what happens here? This is the brief diagram about that. So let's say we are running any particular protocol in the network. So first is that the protocol exchange all the IPv4 information, and then it populates the RIB, that is routing engine base, where you will find all the information related to IPv4. Then label management, that is the entity on the router which take all the routes from the RIB table, assign the label to all of these prefixes or roots, and then advertise those to the neighbors, and we get the prefixes from the neighbor as well. So we store all those information in the label information base, and once we get the base to next of, let's say if we want to go from A to B, so we will figure out that what is the next interface, best interface between A and B. So based on that one, the label information from LIB to the LFIB, label forwarding information base, it will push here, and then packet will forward based on that label value. So it will have the incoming label and it will have the outgoing label.
Right.
Is it clear?
Yes, sir.
Okay, good. So let's say this is the overview of the diagram, and let's say that R1 is advertising those labels for that one, for the prefix R4. So he will say to all the routers, if you want to reach to the R4 via me, then use this particular label 24008 or whatever it may be based on its assignment. And then if R1 wants to reach to the R4 via R2, then he will push this particular label and then send it to the R2, because R2 knows that this particular label belongs to R4. So he switch the packet with the label which he received from R3. And again R3 does the same thing. He switched that packet based on the label received from the R4. So you can see here on the R2 we are checking the LDP lib table, that is label information base. So you can see for the prefix R4 we are seeing that it has generated the 24008, and it is advertising to the neighbor 1 and 3 because R2 is neighbor with the R1 and R3. So it is advertising those labels to these peers or neighbors, and he is getting these
Yes.
labels from the neighbors. From R1 he is getting that 24003, means let's say suppose somewhere we have some link between R1 and R4, and in case if this link goes down, then R2 can use this label to reach R4 via the R1. So that's why all the routers advertise all the labels in all the directions. So that's the reason we see here the label for R4 from the R1, even though we don't have the connectivity between R1 and R4, direct connectivity between R1 and R4. So this is the label advertised by R3 towards the R2. He's saying that if you want to reach to R4 via me, use this particular label. So this is how the control plane works for the multi-protocol label switching. And let's say how exactly forwarding works. So as we discussed
Yes.
earlier, yeah, do you have any query?
No, sir.
Okay. So as we saw in the earlier output, if packet hits on the R1 destined towards the R4, so he will push this particular label on top of that one because R2 has forwarded that label to R1, and then R1 will push that label on top of that one and then forward packet to the R2. R2 just switch that packet because he knows that once he get this packet, he will just swap that label with the another label and switch that packet on the another interface. So it's not doing any processing. That's what we need to remember here, because if it is IP over address, he needs to process. Let's say if we get packet for this particular IP address, so he needs to process that packet in the control plane, and then based on that one, he needs to figure out the next hop. Then it's going to push, and routing takes a lot of time to process those packets. So hence, if you see the packet which is routed via routers, normal packet, so you will see that uh, latency will be high in such a scenario. But here we are just switching that packet, taking packet from one end, and just based on that label value, we know that what is the incoming label and outgoing label. We just switch packet and swap the labels and then send it to the next router. We are not processing that packet here. And then at the last stop, because he knows that by sending this particular label value to the R4 from the R3 doesn't make any sense, because anyhow he needs to process the IP packet. So he R3 removes that top packet. We called it as a penultimate hop popping PHP, and then forward the simple plain IPv4 packets to the R4, and then R4 process that packet based on his requirement. So what is the major difference between MPLS and traditional IP routing? So IP routing is completely work based on the destination IP address. Let's say if we got the 1.1.1.1, so he will look for that particular IP address, he will process that packet, and then he will route that packet via the interface which is going towards the destination. But that is not the case with MPLS. He just switched that packet based on the incoming label. So he will say that my incoming label is X, and I need to send it to this particular interface using the Y label. So he will just swap the X label with Y and immediately push that packet towards the next interface. So that's what routing is very slow compared to switching. because switching I don't need any processing of the packet, and immediately it push on the next interface. That's what it is fast, and that was the main primary reason for the MPLS in the earlier era when MPLS started. But nowadays routers have good CPU, good memory. So nowadays that doesn't make any difference between the IP routing and the switching. But it has some MPLS has some added advantage. That's the reason we still see the MPLS in the service provider networks. So for IP paradigm, there is no defined forwarding path. So let's say packet hits, then router processes that packet and then forward it on the next interface. So it don't have the path that from X to Y destination, this is the certain path packet needs to the follow. But here MPLS will have the label switch path formed between the source and destination based on the labels. IP routing is not secure and it's not fast. It's very slow compared to the MPLS. MPLS is very secure. We will see that in the VPN section how secure it is, and it is faster compared to the IP routing, because here we just switch the packet, we don't process that packet. When any particular packet hits on the router, IP packet sits on the router, so he just push that packet on the next interface which is going towards the destination. He will not see if that particular interface is oversubscribed or overutilized. And then if that particular interface somewhere in the network is already oversubscribed or already overutilized, then whatever packet you are trying to push is bound to drop those packet. But that is not the case with the MPLS. If there is some issue in the network, if there is any congestion in the network, so MPLS can figure out those congestion and then it can route the packet over the another path. So that is used in the resource reservation protocol. For LDP, we don't have that option, but MPLS RSVP has that option where we talk about the traffic engineering. IP don't have any option to handle the multiple protocols. Like it just handle the IP, that's it. But multi-protocol can work, this MPLS can work with the any other protocol, because that packet, whatever is there, it will be any other protocol. Then on top of that, and he will just push the MPLS label and then Ethernet header. That's it. In the traditional IP routing, you will find only single routing table for all the customers. You can't segregate those based on the customers. But that is the biggest advantage with the MPLS networks. We can see that in the detail in the VPN section where each customer has their own separate routing table, and it's become secure as well. If X and Y customer has separate routing table, so they can't have the reachability between each other. But in this case, if they are both part of the same routing table, then they can have reachability and it's not the secure for the customer. So this is it about the MPLS and then traditional IP routing. Any query on this one?
Sai Durga, do you have any queries? You can write in the chat box if you have a network issue.
Okay, so Next one is the MPLS traffic engineering and QoS. So what is the MPLS traffic engineering? Traffic engineering means you route your traffic according to your requirement. That feature is not available with the traditional IP routing algorithm. Means let's say if your particular customer has the high bandwidth, then we can route that particular packets through the interfaces which has the higher bandwidth. Let's say the Y customer has the latency. Let's say he is running the voice over IP services. In that case, we need very low latency. Then in our network, we will see that which links or interfaces has lower latency. Then we can route that particular traffic over that particular links. So we have multiple options which we can define based on the customer requirements. That's why we called it as a traffic engineering, because we modify those paths in the network based on the customer requirement, but we don't have that option with the traditional IP routing. So let's say that these are two customers, VRF A, VRF B. So this end it is VRF B and VRF A. So let's say that VRF A customers has the higher bandwidth requirement. So then based on his requirement, we can route this particular traffic over the links which has the higher bandwidth available in the network. And let's say that we are a B2B, they need the lower delay or lower latency. Then we can route his traffic via the links which are lower latency in the network. So that's what we call as the traffic engineering, because we modify their path based on the customer requirement. It could be the bandwidth, it could be delay, latency, or any other stuff which customer needs. And for this traffic engineering, we use the RSVP protocol in the MPLS, that is resource reservation protocol. In the QoS, if we talk about this first feature, let's say that one ambulance is coming on this particular road. Do we think that ambulance will get the way to reach his destination? Looks to be very difficult by looking at the traffic scenario. So this is how the network without QoS works like this. Traffic is coming from any other direction. None of the traffic is having any priority. All of the traffic is trying to leave the port at the same time. So the traffic which has the importance or emergency or priority, it can get dropped or it has to wait in the network. But if you see this particular scenario, this particular path, then the slower moving vehicles can this, then second slower moving vehicles can go at this path, and then overtaking vehicles can go at this path. So this particular picture indicates here the proper QoS treatment on the router, because we have defined the priority that ambulance needs to be first priority and the steps we need the second priority. So based on our the priority, network will act like that. So in the general scenario, we see that audio traffic has the most priority in the network. Because let's say that if you're calling to someone else and if there is delay, that even 50 millisecond delay is also very lot for this audio traffic. Let's say if you're calling to someone and you listen that voice after some delay, so it's become very confusing to talk over that delay. Because I believe same thing happens for the WhatsApp call, that traffic is getting routed via the internet. To avoid that one, audio traffic or VoIP traffic has the most priority in the network. And we define that priority for the MPLS packets. Then next one comes as a video. If there is long for the video, it's not acceptable in the network. So in the general scenario, video will have the second most priority. And then rest of the traffic has the least priority, like web traffic. Even though if I am trying to reach to the Google and let's say that bandwidth is not available in the network, but still I can refresh and I can get that page back. So all this traffic we put in the base effort. So let's say this is the outgoing interface. So first traffic will be voice, then second traffic will go video, and then last, if bandwidth is available, then last it will be this base efforts traffic. So this is how QoS works for the MPLS, and we have the EXP bit mark for that. That is called as an experimental bit. You can set it in the network based on your requirement, and you can configure on the routers how you should act this particular EXP. So if you see here this packet capture, here MPLS EXP it mark as a 0. 0 means it considered as a base effort. So this is how the QoS works for the MPLS. Next, we will check the VPN, that is virtual private network. Let's say we have two customer on the particular routers, and first is that they don't want to share their routing table. So we need to have this separate routing table for both of them. Otherwise, this particular customer can attack to this customer and it will have huge impact in his network. To avoid that one, the routing separation is done using the MPLS VPN that we call as a VRF, virtual router and forwarding instance. And based on that one, we forward a packet using the MPLS headers. Let's see how that is works. So this is the simple topology for that. This is the CE1 customer edge router, which is having 11.11.11.11. This is 22.22.22.22. This is CE2. And let's say this is the complete MPLS network. So based on the border gateway protocol, we exchange the label information between both R1 and R4. So we form the BGP. So for 22 prefix, it exchange the label values with R1. He says that if you want to reach to the 22 prefix, use this particular label. So in this case, R4 is saying that if you want to reach to 22, then use this 2400 VPN label for that. And then top level will be to reach to the R4 because R4 is acting as a next stop. Because in my network, I don't know about the CE2 or in the case of R1. Because I'm part of the MPLS domain where I know only R1, R2, R3, and R4. I don't know about the CE2. So R4 says that if you want to reach to the CE2, use this label. Okay, that I used. But how I can reach to CE2? Via which router? So for that one also, I'll need the MPLS label. So you can see that for the VPN vPOS scenario, we push the two level stack on top of that one. And that's where we maintain the security. That's what we call the VPN is MPLS VPN is secure network, because we use the separate VPN label for each and every customer. And let's say that we have another customer here which will have the separate VPN label, but he can't use the same VPN label to reach to the CE2. That's why it is very secure from the customer perspective. If it comes to R2, sorry, VPN label will remain same, and then R2 will push the or swap the label to reach to the R4 which he received from R3, and he will switch the packet on this particular interface. So here for R3 and R4 is directly connected. So in the MPLS term, we called it as a penultimate hop popping, because both are directly connected. So I don't need any label on top of that one. So I'll remove this label and I'll forward this only VPN label to R4. And R4 will say that, okay, this VPN label I have assigned it for CE2, and then based on that one, it will switch packet towards this particular interface. This is how the MPLS VPN works. And this is the trace route from the CE1, this device, towards the CE2. So you can see that R1 has pushed the two level stack. This is VPN label and this is the label to reach R4. Here again we saw the two levels, VPN label and label to reach R4. And then at the router 3, it has removed the top label because he know that he is directly connected to R4. So he removes that top level and he just push the VPN label towards that one. And VPN, based on VPN label, R4 knows that this is the label which I assigned for CE2. So he will remove that label and he will switch that traffic towards the CE2. And this is the Wireshark snippet for that. So you can see that this is the top label for R4 and this is the VPN label for CE2. And then along with all those information, MPLS, EXP bit, then bottom up label stack, and then TTL value. So let's just discuss brief about the use cases. So first major use case is in the service provider network. So if you talk about the Airtel or Reliance Jio, they are using this MPLS technology in their network. And majorly it used for the VPN services and for the broadband services as well. Because whatever broadband you are receiving from the service providers, it comes via the MPLS domain. Second use case is for the enterprise network. So as we discussed earlier, if someone needs the traffic engineering, so MPLS is best option for that one, because you can utilize all the resources in the network, because you know that this particular link is overutilized and I don't want to push that traffic further on this particular interface, but I can utilize the underutilized link in my network. In that scenario, I can use the MPLS traffic engineering. Third one is QoS. as we discussed earlier, that if we need to prioritize some traffic over the other traffic like voice over IP or other streaming services, we can use this MPLS to prioritize all those information. Then for the disaster recovery, so MPLS has that features in his network that in case if there is any failure in the network or any particular link is got failed in his network, he has that capability to reroute that traffic within 50 milliseconds. Means even customer can't even notice that okay there was failure in the Airtel network and he has some issue due to that. So traffic will get rerouted within 50 milliseconds. Very quick and fast recovery. This MPLS also can be used for the data center connectivity. So if customer has the data center, one location is in Europe and one location is in India and then third location is in US. So we have that option to connect all those data center using the MPLS. And this is the second major use case, that is mobile backhaul. This was the first major use case and then second one is the major mobile backhaul. Because whatever mobile traffic you are using nowadays, it is going via the MPLS. So whether you are using the Airtel or Jio, all this traffic is going via this MPLS network. And then it can provide the video and IPTV services over the MPLS. And then last one is the real-time application like VoIP and all those stuff. So as we discuss here, based on QoS, we can prioritize this particular traffics in the MPLS network. This is brief about the use cases, and that's it for this today's session. Let me know if you have any query on this one.